Record it will be. Okay, so we are going to look at subtraction of vectors. Jake has a question before we begin.
Well, would you ever use that for previous always addition? Like when we do need to subtract?
Hold on to that thought. Okay, we'll get there. All right, so I've shown you the video. What do you think it means? Addition means place tip to tail, right? I think there's supposed to be something else here. Where is it? Right there. Now, if you subtract scalar numbers, we can rewrite scalar addition as subtraction, right? And you probably saw this in some form of introduction to integers, right? Something like 10, you don't have to write any of this down here. You can if you want, but you don't have to. 10 minus 6 is the same as 10 plus minus 6, right? Ten minus 6 is the same as 10 plus negative 6. Agreed? Okay. And negative 6 is the negative of plus 6, right? Okay. So, the negative of a vector, then, I'm supposed to ask a question. And it's probably down here somewhere. Yeah, there it is. Subtraction of vectors can be done the same way. What is the negative of a vector?
Same magnitude of direction.
Exactly. And we got that from the video. The negative of a vector is a vector having the same magnitude, but the exact opposite direction. You might want to jot some of these down here. So if A is to the right, well, negative A is to the left, right? If B is up to the right, negative B is down to the left. I'll pause there for a second. So, we've got the A and the B, no problem. C, if C is a direction of 0, 1, 0, or a bearing of 10, which way is that? Kind of in words. Kind of on the clock, what number would it point to? Around 1 o'clock, right? So there's my reference. It would be like up like that, right? That would be 10. So what's minus C then? 190? Is that you, Jason, said that? How did Jason get 190, do you think? Added 180. Exactly. 190, right? The opposite, pull 180. Exact opposite, reverse direction. Minus C would be 190. Do you always add 180? Well, what if I've got 300, Steve? Can I add 180? You could. Add 180 to 300, you're going to get 480.
No, you won't.
Then you got to subtract 360. What if instead of adding 180, you just go, instead of clockwise 180, you go counterclockwise 180, which is a subtraction of 180, is it not? Right? So in other words, you add or subtract 180. I'll put the negative is like this. Right here in black, 300 is like that, and 120 is down like this. Okay? So if it's the bearing method, you just add or subtract 180 depending on whether you're starting with less than 180 or more than 180, right? What if you got something like south 15 east? Jason says north 15 west. Everybody says? Agree? Huh? Really?
No. East 15 something.
Okay, well let's work through it here. South 15 east is going to be in black. 15 like that, right? I know it's not the scale. Oh, sorry, that's west.
That's west.
Yeah. That's west. South 15 east, right? Exact opposite is going to be like that. North 15 west. I think that's what Jason said. Am I right? Exactly. North 15 west. Okay? So that's sort of the rules for doing the flip. Right? Add or subtract 180. If it's this kind of thing, then all you do is what? South becomes north, east becomes west. Right? Or vice versa. All good? Well, let's see how you do on the little quiz thing here. I started? Yes. What's the negative of 10 meters per second east? 10 meters per second east. A, B, C, or D? All right, what's your answer? Correct answer is B. Yes. Correct answer is B. 10 meters per second east would be, the opposite would be 10 meters per second west. Did I trick you with the minus 10 west?
Yeah.
Yeah. Yeah.
I pressed the delete button and did it.
Okay. It's all good. See, most people got that. Okay. What about this one here? If vector x is 25 kilometers per hour at north 30 east, what is negative x? Opposite. Correct answer? Everybody get it? Yay! Correct answer is D. You can do vector subtraction. I got a little hard. Okay. So, how do we do vector subtraction? To subtract vectors, find the inverse of the vector to be subtracted. So you have to identify which one you have to subtract. Does it matter?
No.
Is 10 minus 6 the same thing as 6 minus 10?
Yes.
No.
That was
No. It's not. 10 minus 6 is 4. 6 minus 10 is minus 4. Kind of the same, yet different. Okay? So yes, it does matter which one you flip. Subtract vectors, find the inverse of the vector to be subtracted, and add it tip to tail to the other one. So here's A, and here's B. Where is my negative B? Is it here? Okay, I'm going to have to... How am I going to do this? Okay, you want to do this? And you can, that is actually, some textbooks teach it like that tip-to-tip thing. I have, it's fine. I would prefer it to be tip-to-tail. Okay, so how am I going to do that? I'm going to make a copy of this, right? Copy. And then I'm going to flip it upside down by switching the arrow here. Okay, and then I'm going to call this what? This is going to be minus B, right? And then I'm going to take A. Now here doesn't matter what order I do them in. Like, can I go like this, A and minus B? Can I do that?
Yeah.
Is that the same as minus B and an A?
Yeah.
Is it?
Yes, it is. No, yes, it is.
Okay, well, let's just see here. I'll leave this one, right? So where's my resultant here? I've got, yeah, so my result, now where does it start? At the back end here of minus B, so it's going to be like this, right? Now, is that the same as if I take this one and copy it? Paste it over there, and I take A here, and I copy that. And I paste it over here. Now here, if I'm going, oops. Here I want to go A and then a minus B, right? A minus B, is it the same thing? So that doesn't matter. Okay? Doesn't matter. But it does matter which one you flip. Okay? So the rule is flip the one that has to be subtracted and then do what? Just add them. Right? It just becomes an add question. Flip the one that needs to be subtracted and then add them. Okay. Here's an example. This you need to write down. The biggest problem with vector subtraction is kids don't know when do I subtract. And I'll go through that. I made a little change to this little lesson today, so I'm hoping that helps with you. Okay? So jot this down and then we'll do it together here. Okay. Now, we know which one to flip.
No, B.
The B. It says A minus B, doesn't it?
Yes, yeah.
We flip the B. Okay, so I'm going to go 10 meters north, right? So my A is going to be like this. Now I have the luxury that I can draw on here, and then I can move things around. You sort of got to, when you're doing vector stuff on a piece of paper, you sort of got to plan it ahead a little bit so you don't run off the edge. That happened to you guys the other day, right? Okay. It only,
It was close to that.
oh, okay. It shouldn't happen, but generally start your questions kind of in the middle of a white space. Don't start them in the top left-hand corner because you will run out of room. Okay, so that's my 10 north. Now, 15 meters east would be like that, right? So this is my A, and this is my, did you draw it? Did you draw it already?
No.
Because what did I do? I didn't, I gotta flip this one, don't I?
The 10 meters is longer than the 15.
Yeah, you're right. So that one's north, so the 15 actually has to be like that, right, Steve?
Yes.
Yeah, I'm not doing it to scale. Yeah, I have this luxury that I can do this. Right? Now, is that right? Yeah, right, yeah. Where is the resultant from? From where you start to where you end. Now,
When we draw our results, it's supposed to be a dotted line.
it can be. I just like to so that you can see. It doesn't have to be. I know in some textbooks they show it with like a double line, or there's all kinds of different ways to do it. Okay, and we're basically going to call it the result. You know how when you're adding numbers they call it the sum, and when you subtract they call it the difference? To my knowledge, there is no special word for an answer to a vector subtraction. We'll call it result. I don't know. I could be wrong. I've never heard it. Okay, so that's just A minus B. That's relatively easy. How am I going to solve that? Well, because I've got north and east, I could actually do what? I can actually do Pythagoras, right? I can actually go r squared is equal to, this one here is 10, that one's there 15, so it's going to be 10 squared plus 15 squared. Does it matter which order I put those? Like, could it be 15 squared plus 10 squared?
Yes.
Of course. 100, 15 squared, 225, and so my r value is the square root of 325, and I regret to inform you that I cannot do that in my head. Okay.
Yes.
You guys don't know your square roots up to 500? That's weird. Where's my angle? In there? Opposite over adjacent, right? So it's going to be theta is equal to inverse tan of opposite over adjacent, 15 over 10. And I do not know my tangent table either on the top of my head. How much?
It's 56 degrees.
Okay, 56 degrees. And that's actually going to be north, 56 west, right? Yeah? Could I have done it by scale drawing? Absolutely. Would I have gotten it accurately? No. If you can, do by scale drawing. Pardon me?
Wouldn't be as fun.
Well, that's certainly debatable, Jake. What is one man's fun might be another man's job. Hey, guess what's coming next? That almost sounded like it was Pirate Day again. Vector A is 5 meters per second north, and vector B is 4 meters per second west. Which diagram best shows A minus B? How we do? Just one individual. The correct answer is C. Okay, vector A is 5 north. 5 north, right? Is that one? And then 4 meters per second west becomes actually east. Vector subtraction. Good? Yeah? Okay. You said this was going to be hard, but it isn't hard yet.
No, it is hard.
Is it hard yet?
No.
Okay.
Is it going to get harder?
You tell me. Here's where it gets hard. Again, This is one of those things that academics, teachers, professors go crazy with notation and make it all hard. Hang in there. Okay? Hang in there. Don't write this down. You don't need this. You can if you want, but like just watch. Watch and learn. Displacement. What does displacement mean? Like,
Distance from one.
how much an object moved, right? From where it was. You think about Bobby McFerrin, from where it was to where it was, or where it is, right? I went, what did I do? So my displacement would be?
2 steps left.
Give that to me in a plus negative notation.
2 yards plus.
This is plus 2. Is an object plus 2? 2 yards east, fair enough, right? Assuming that to the right is and positive. Fair enough. Everybody gets that, right? Maybe not on the pentatonic scale, certainly, but okay. So now, what the heck does this mean right here? Delta D is crazy physics code for displacement. XF is crazy physics code for Jake? Final position, very good. And XI is crazy physics code for Jake? Initial position, very good. So an object is on a number line at an initial position of plus 3. Right there. It ends up at a final position of minus 3. Find its displacement. It went
Plus 6.
It went what? Why do you have to make it all crazy hard with vectors, Mr. Ben? Well, the point is not so you can do this, because we can all do this. It's to take the concept and to apply it to a little more complicated situations. You have to understand the process first, and that's what I did here. Okay, so if I were to write underneath here, xf minus xi, what's my final position? Minus 3. My final position is minus 3. And then I subtract minus 3, right, Hannah? Where did I end up? That's what final position is. Where did I start? Plus 3. So minus, not minus 3, minus plus 3. Well, this is just integer stuff from grade, I don't know, 7 or 8. Minus 3 subtract plus 3. Still not that complicated, right? A little bit confusing, this kind of stuff, but really. Okay, now, instead of being one-dimensional, just, 1, 2, it's 1, 2, and 3 forward. 2 dimensions. Now I have to deal with vectors. Is displacement still the same thing? Is displacement final minus initial?
Yes.
Yes, the only difference being they're now vectors. And how do we subtract vectors? We flip this one and then we add. That's all it is. Really is that simple. Okay, I hope that's the next slide. Okay. Write this down.
The question?
The question. Write this down. Draw a nice little truck down in the bottom left-hand corner. The question says, a hunter is at an original position of 500 meters east from his truck. He walks for a while and ends up 750 meters north of his truck. What was his displacement? Okay. Move this up another way. Where is he initially? Liam? Roughly where is that?
Way to the right.
Somewhere like over here?
Bottom.
Maybe not that far. If I go that far, maybe I'm using up too much space, right? Do I need to worry about a scale here?
No.
It's probably a good idea to draw a little sketch, and then if you have to solve it with a scale, draw another one. So let's just draw a little sketch. Okay, so 500 meters east from his truck. Now,
5 centimeters.
you can do that, yeah. I'm just going to label this 500, and I apologize if you can't see that way down there. Now, did he walk along that black line from the truck to the end of that arrow?
No, she's there.
We don't know. He might have. He might have teleported. He might have skipped. Aliens may have abducted him and dropped him there. Jimmy cracked corn. I don't care. He's there. I don't care how he got there. Please don't get the idea that this shows how he got there. It just shows where he is in relation to the truck. We would even call the truck, could be so bold to call the truck the origin, or a reference point. More on that next unit. It's a reference point. Okay? So that's where he is. I'm going to label that. If I were to label that XI or XF, which one would I choose?
XFI.
Which one, Joey?
I.
XI, because that is his initial position. He's standing right here. There he is. He's got a displaced hip. And a crooked neck. Okay, where is he at the end of this? 750 meters north of his truck. Like up here?
North of the truck.
Of the truck. Do I draw an arrow from his truck up there?
No.
Yes.
Well, that would end up being the result of
Yes.
from the
Yeah,
original
yeah.
price.
Does he go from the truck to there?
No.
No, that's not what that shows. It is a position vector. It shows where he is in relation to the truck. Now, if I were to go back one step here, let's go back one slide. Oh, two. Where was I to begin with? I was at +3. Did I walk from 0 to +3? Don't know, don't care. Where did I end up? At -3. How did I get there? Did I go from 0 to -3, or did I go from... I did that, right? What's the origin here? The 0, right? When I say +3, that means I'm 3 to the right of. And when I say -3, I'm 3 to the left of. And the 0 is the same as the truck. It's an origin. It's a reference point. I repeat, I do not walk from the truck to the XI, and I definitely do not go from the truck to there, and I would label this my XF. The only walking that he does is from where to where, Anderson? I'm going to draw this in blue. What did you say, Jake? Oh, who is it, Joey? So, like, right here, Joey, you're saying, like, start him there, and you want me to, like, can I do this?
That's exactly what it did.
Well, I should have waited till Halloween, perhaps. Yes, I think. Oh no, don't do that. That's basically what happened, right? Well, except for leaving his head. He walks from there to there. That is my displacement. That's a terrible deed. Now, you might say, Mr. Bennett, you just solved the question without doing any vector subtraction at all, didn't I?
No, you didn't.
I did, because really, I've got the displacement. If this is a scale drawing, I can measure that and I can get my answer. Did I do any flipping here?
No.
No. Unfortunately, that's not good enough for me. The outcome here is that you have to understand vector subtraction. I didn't do vector subtraction. I just drew a nice picture. Okay, so how do I do vector subtraction? Delta V is final minus initial. What's my final? It's this one, up and down, right? This black one, XF. So it's going to be like that. There's my XF. Now, what does my negative XI look like? XI is to the right. Other way. So is this what you're telling me?
Yeah.
And I'm not doing it to scale, I'm just drawing it, right? Is that what you're telling me?
Yeah.
Yes, and that is 100% correct. 100%. And now my resultant is from where to where? From here to there. My displacement. How come, Mr. Bennett, how come this blue arrow right here isn't the same length as that one?
It's not the scale.
It's not the scale. And it doesn't have to be because I'm going to use Pythagoras here, right? This is a diagram, kind of like a picture of the world, of what we actually see. Remember, it's got a real truck in there and a real guy. This one is a vector diagram, or a vector, no, I would call it a vector diagram. Okay, those are actually vectors. These are arrows. These are arrows. They could be vectors, but they're not. I haven't arranged them as a vector. This is. Now, here my displacement then, I'm going to go d squared is equal to 500 squared plus 750 squared, and I'm pretty sure you can solve the math there. All I know for sure is it's less more than 750. It's probably over 1,000, I think. Is it over 1,000, right?
Is it over 1,000? Yeah.
Yeah?
Yeah. About 56.
56,000?
Yeah.
Did you take the square root?
Oh no, not the end.
Oh yeah, I need the square root. Yeah.
Like you're talking about just like the square roots themselves.
That sounds right. Maybe it's not over 1,000. 901?
0.9.
Close enough. 901. Am I done? Regrettably, no. Now, I haven't talked to you about this rule, but the rule being that if I give you in the question, if I say something like east or north in the question, there's a pretty good chance you're going to need to give me a direction back in the answer. How come? Because it's a vector question, right? So, where's my vector or where's my angle? Right there. Okay, so now it's going to be theta equals inverse tan, opposite over adjacent. Now my xi here is the 500. 750. Again, I apologize that it's down so low there. I really got to get my calculator out so I can do these questions. I know I'm throwing a lot at you here. I realize that. I know that. It's okay. I don't expect you to get it first crack. Can somebody give me that angle?
33.7.
33.7? We'll say 34. That's going to be now north, 34 west. Okay, so if you're thinking like a test kind of thing, I would give you likely 1 mark. 1 mark for this vector diagram. You need to show me that you get subtraction. I probably wouldn't give you a mark for this diagram down here on the left. I would give you a mark for the vector diagram showing that you've flipped and put tip to tail. Okay, showing that you flipped the minus xi and that you put them tip to tail. That would be worth a mark. I understand vector subtraction. I know I have to flip them. One other mark for coming up with the 901. I know how to solve the magnitude. And another mark for coming up with the angle. I know how to solve the angle. Did I make it too complicated?
How do you get the angle on the calculator? How do you calculate?
You go, it depends on your calculator. Some of you will have to go 500 divided by 750 equals second function tan. Some of you go second function tan bracket 500 divided by 750 bracket equals.
Yeah, I got it.
Yeah.
I still got it.
Are we going to use the filters again?
Oh yeah.
That's a bit of a concern. Perhaps we better have a closer look here, right? Okay, it's one thing to be wrong, but if you're wrong, let's figure out what you did wrong, right? Okay, so which one of these things, let's go through here. A hiker is 1.5 kilometers east of a campsite. Is that initial or final? Initial. XI. So my initial is to the right, 5. Then walks a while and ends up 6.6 kilometers south of the campsite. So my final is like that, right? Yeah. So vector subtraction, final minus initial. So there's the down, and then this one here, right? Yeah?
Yeah.
Now, would you agree or disagree that reading's going to be pretty important here? Yeah, I think so. Reading's going to be pretty important here. Okay, I hope you got that question wrote down, because now I'm going to ask you same thing, except what's the magnitude of the displacement? How far are they from where they started? Okay? You have to actually type in a number correctly rounded to 1 decimal place. Don't give me that what? 1.5 east, final, so it's 0.6, right? $1.5. So, go. Well, we did pretty well. Correct answer is 1.6.
Took us 2 minutes though.
Some of you may have rounded poorly. Yeah. Okay, so 1.6, it's 1.5 squared plus 0.6 squared. Take the square root, make sure you round correctly. Guess what I'm going to ask next? What's the angle of the displacement? Again, I'll draw the picture for you. It's 1.5 east is my xi. My xf is 0.6, so it's final minus initial. 0.6, that's my final. My minus initial is like that. My minus xi, and that is 1.5 long. So what angle is that in there? Again, I point out grade 9 trigonometry. And I don't think I'm going to finish this.
You have to start.
Oh, sorry. Do we even need a calculator?
No.
The angle is 68, 68, 68, 68. Guess what the answer is?
72.
Yeah, 68. It's clearly south and then west. Well done, Ryan. You're probably gonna have to take your stuff home tonight, sit down in a nice quiet spot, put the phone away like Joy's going to right away.
Look, this is my belt. See?
You're texting with your belt?
Yeah, I gave my belt.
Okay.
Take him out, Joey.
You shouldn't assume the texting pose when you're playing with your belt.
Sorry. I'll sit on.
You're probably going to have to go home tonight and say, and you know what, 2 or 3 minutes, look at it and just think again about it. Okay? It really will make a difference if you do that. Okay. Having said all that, I got 5 minutes. Okay? I got 5 minutes. Stick with me here. I'm going to try to get through this all. How will you know how to subtract? Year after year after year, I get kids saying to me, the hardest part, Mr. Bennett, is I never know when to subtract. But I'm adding this to the lesson. I don't usually do this. How will you know to subtract? When it says minus is clue number 1.
Nowhere.
If it says subtract A minus B, well, then you take A, you make a copy of B, okay, and you flip it around. Actually, I think the recording, when I tried it, wouldn't flip it around, but I labeled it minus B. Then I'm going to add A. Going to move A down. Move A down. There we go. Then I'm going to add B, the negative one, tip the tail. It's going to show up the other way when it's all done. And then there's my result, right? It's going to show it right away. It's going to flip it. When it's done here, there's A minus B, and then it should flip it here, right? Yeah. Now, recording maybe isn't always the best, right? But it should be like that, right? Okay, so that's the easy one, when it says subtract. The second one is, if they talk about displacement. Displacement is the key word, because displacement means what's the difference between where I was and where I am, right? So it talks about displacement. If it talks about final position and initial position, same thing, right? Displacement is final minus initial. So final minus initial. Now, do I do this? No, I take this and I flip it around like that and make it negative. Then I go like this. Always flip the one you're subtracting, right? And displacement is displacement always final minus initial? Yes, and I don't use the word always unless I absolutely mean always. It is always, always. Don't start packing up. I'm not done. Don't stop. Don't start. I can hear it. Don't start. Okay? Now the last one, and I will have to go through this tomorrow. Okay? I'll just do this one tomorrow because it's out of court. Okay? It implies subtraction because it's asking for the wind or plane speed or the current or boat speed. Okay? I'm going to go through that tomorrow because that's the hardest one. So first thing tomorrow is I'll review subtraction and then I'll do this one. Okay? Good? All right.
That works because the wind is pushing against the